video is about what is the value of E, or what is E, and we're going to show where E comes from using what we know about compound interest. So here's an example that was at the end of the classwork that we didn't get to. And so compound interest is when we are applying interest again and again and again. And so we're earning interest upon our interest. And usually we're given an amount of time that we're going to leave our money in the bank account or whatever is earning interest. And then we have that specific amount of money. And then we have the annual percentage rate, which tells us how much interest we're earning per year. And if we compound, in this example, the $1,000, if we compound it at 6% APR annually, it means that we only have one compounding per year. We compound the interest at the end of the year, that's it. And then at the end of the next year, and then at the end of the next year. So we earn 6% on our $1,000. Then the next year after that, we earn 6% on whatever amount we have. So after 5 years, we'd be left with $1,338.23 after 5 years if we were compounding annually. But if we compound that interest 4 times per year, in other words, after 3 months, we get a quarter of our APR, and then, which is 1.5%, and then after another 3 months, we get another 1.5% interest on our new balance, and we keep doing that every 3 months. We earn 1.5%. That would get us, at the end of 5 years, $1,346.86. If we did this monthly, this would be our amount after 5 years. Daily, this would be our amount after 5 years. Hourly, this would be the amount after 5 years. And let's look at this a little bit more closely. So notice that we are compounding more and more and more. When we're compounding hourly, that means we're compounding 8,760 times per year. And we got more money. But how much more money? So if we look after 1 year between compounding after 5 years, compounding annually compared to quarterly, we got about, what was that, $8 more, $8.50 more, which that's not a huge amount of money. You're not going to buy a new car with $8.50, but I'd rather have that. $8.50 is something. I can get something out of that. So that's pretty good. Quarterly seems to be substantially better than annually. But what if we do monthly instead of quarterly? Well, look at that. We only increase our amount by $2. That's less substantial. We're not earning that much more money. If we go to daily, look, that's less than $1 more. If we go to hourly, that was only 3 cents more between daily and hourly. Even though we're compounding so much more frequently, we still only earned 3 cents more. So it seems like the more we compound, we are getting more money, but how much more is decreasing. So what would happen if we compounded continuously? Meaning that we're compounding it all the time, continuously. There's never an instant it's not being compounded. That seems odd. Shouldn't we have infinity money? Because if we're constantly getting interest upon interest upon interest upon interest at every instant, shouldn't we have infinity money at the end? Well, if we look, it doesn't seem like, this seems to maybe approaching a limit. So if we compound it continuously, the balance will be approaching some limit here. There is a limit to this. Just because we're doing it continuously doesn't mean that the balance is unbounded. It seems to be bounded by a certain amount. What is that limit? That's what we want to explore here. How do we figure out what that limit is? So we're going to start with our compound interest formula. Ignore that m equals n over r. We'll get to that later. So we have a, our amount is equal to p times 1 plus r over n to the n times t power. And if we remember, a is the amount of money we have. At the end, p is the principal, R is the APR, the annual percentage rate. N is the number of times compounded, right? So that matches this N right here. And T is the amount of years. So we have to look at that. And what's really changing here? Well, in this table, the only thing that's changing is N. The P is the same, the R is the same, the T is the same, right? The P was $1,000, the R is 6% or 0.06, T is 5 because we're leaving it in the bank account for 5 years. So N is our independent variable that's changing in this table, causing an effect in A, the amount of money that we actually have. So N is the variable that's changing. However, because we have some other stuff going on here, it's going to be difficult to really isolate what's happening. So what we want is, we kind of want to take this, get this R out of here. If we can get that R out of there, that would make things easier for us. So we're going to do a little manipulation. We're going to let M equal N over R. We're introducing a new variable called M. And we're saying M is just N divided by R. The reason we're going to do this is just to make things easier for us to evaluate later. So it's a little trick. So if M is equal to N over R, that means that N is equal to M times R. So what we're going to do is we're going to go up here and we're going to replace N with M times R. So that gives us A equals P times 1 plus, we had R over N, but now we have R over M times R. We're replacing it. And instead of N times T, we have MR times T. So let's simplify a little bit. We can cancel out those R's, right? So we're left with A is equal to P times 1 plus 1 over M to the MRT. All right, but now we're going to use our laws of exponents, and we're going to write this as A is equal to P times 1 plus 1 over M to the M power, all to the RT power. Using our laws of exponents, we can do that. If you don't remember that, time to review your laws of exponents. So now what do we have? Well, we have here, it's the same exact thing, but now we don't have this R being raised to a power. So it's going to be easier for us to see what's going on here. Why? Because, well, what's really changing? Just M. And M is changing. And all our M's are contained right here. So we can ignore all the other parts. All we care about is this 1 plus 1 over M to the M power. That's the only part that matters to us right now, because that's the part that's really affecting our change. Okay, so what do we do with that? Well, remember, M was equal to N over R. So that means that as N goes to infinity, right, the number of times we're compounding goes to infinity, M will also go to infinity, right? As N gets really, 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 really huge, M will also get really, 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 really huge. So then, as the number of times we compound per year increases, M also increases. Not only does it increase, it's unbounded, right? As N goes to infinity, M also goes to infinity. So that means what we're really looking for to see what effect this has as N goes to infinity is to see what happens as M goes to infinity. So we need to find this limit. The limit as 1 plus 1 over M to the M power as M goes to infinity. We want to see what happens. How do we do that? Well, that's your job. So your job for this homework is to evaluate that limit. Find that limit. That's your job. Now, I'm going to give you a hint. This is not a limit that you know how to find analytically. So luckily, in Unit 2, we learned several other ways to find the value of a limit, even if we couldn't evaluate it analytically. All right, so if you need to review Unit 2, how do we find limits when we don't know how to evaluate it analytically? And we're looking, remember, as M goes to infinity. So think about what that's going to do. Then answer the questions in the homework form after you have found that limit.